welcome back. I hope you remember in which chapter we were. We are studying chapter number 3, current electricity, and we'll be continuing with symbols or for components of an electric circuit and their uses. So, what is an electric cell? If you all had noticed how a clock works with the electric cell, so this is a sort of, you can compare it with this cell which we have in our watch nowadays, in our clocks, in our remotes, in our AC remote, and many other things. So this is a symbol plus and minus, that is the positively where there is the negatively charged. To apply potential, what is the use of that? To apply potential difference between the two ends of the conductor. Now we'll be saying okay, what component it is and the picture of that particular component and the actual use, how and where it is used in an electric circuit. Battery, to apply larger potential difference between the two ends of the conductor. One tap key or the plug key, which we usually play with it. So to stop the flow of the current flowing in the circuit by disconnecting two ends of a wire. Closed tap key or plug key, to start the flow of the current in the circuit by connecting two ends of a wire. Connecting wires, to connect various components in the circuit, crossing wires to show wires which cross but are not connected, light bulb and all. You can see many things. The voltmeter to measure the potential difference as we had discussed before, ammeter to measure the current flowing in the circuit, resistance to change the resistance as required and thereby control the current. You have to see to it that resistance is applied to control the current. We don't want at the time if the flow of charges continue moving, so what is generated? Heat is generated, and due to that heat, many disastrous events or the accidents do happen. So resistance is present so that it can control the current flowing. Now moving with the conductors and insulators. What conductors are those substances which have very low resistance are called conductors, whereas insulators are those substances which have extremely high resistance and through which current cannot flow are called insulators. Now we'll be seeing key system of resistors and effective resistance. In here we'll be discussing two ways of connecting resistances. That is, the first one is in series, the second one is in parallel way. Resistors in series, you can see here they are aligned side by side, like they are sitting in one bench. Three students are sitting, so they are connected in that way, that they are connected side by side. So R1, R2, 2 and R3. The, whenever you see this type of design of a resistance, this is called the resistance in series. These resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. You can see here what it is written. The same current flows through each resistor. The value of the current is I and the potential difference is V. And we have to say to it, okay, whenever the resistance is connected in series, then we have to add up all the values of the potential differences. And as we had seen in Ohm's law, the relation of potential difference is with the current and the resistance is V is equals to I into R. If V is being added up, so obviously even R needs to be added. Now we'll be seeing okay, how resistors are connected in parallel. Resistors are said to be connected in parallel when the ends are connected at both the sides. Like they don't meet to each other. You know, we have seen many parallel lines. This is how they are connected. The figure shows three resistors R1, R2 and R3 connected in parallel between two points C, D. V is the potential difference, whereas the D, C and D are the points. I1, I2 and I3 may be the current flowing, whereas the R1, R2 and R3 are the resistors applied. So we have to see to it, in here we have to change something, that is V is equals to I into R, right? So in here, when we see the resistors connected in parallel way, we have to see, okay, we have to make our equation from the current side. if we take I, that is current, opposite to the is equals to sign, so I is equals to V upon R. So I is I is equals to V upon R is our general formula for the resistance connected in parallel ways. So the final will be 1 upon Rp, that is the total resistance is 1 upon R1 plus 1 upon R2 plus 1 upon R3 to the 1 upon Rn, that is is n defines the n number of, that is, this is in compulsory circuit. There will be only three resistors connected. There will be n numbers of resistance connected, 1 to 100 to thousands and all, if you consider. So this is where we end our chapter. Bye.